inverse function, how we can find an inverse function. So notice that these steps undo each other. Functions that undo each other are called inverse functions. In example 1, you can use the equation solved for x to write the inverse of f by switching the roles of x and y. F of x equals 2x plus 3 is our original function, and g of x equals x minus 3 over 2 is our inverse function. Because inverse functions interchange the input and output values of the original function, the domain and range are also interchanged. So if you look at our original function, compare it to our inverse function, you'll notice that the y values become our x values, and our x values become our y values from one function to the other. There's also a reflection. So the graph of an inverse is a reflection of the graph of the original function. The line of reflection is y equals x. That is the equation y equals x. To find the inverse of a function algebraically, switch the roles of x and y, then solve for y. So how to find the inverse of a function? So first thing is to replace f of x with y. Then switch x and y. Use algebra to resolve for y. Write the function, the new function, using inverse notation. So inverse has this little -1. So this means that it's the inverse of f of x. So example 1, finding the inverse of a linear function. So we need to find the inverse of f of x equals 3x minus 1. So we have f of x equals 3x minus 1. So our first step was to replace f of x with y. So y equals 3x minus 1. And then we need to switch the x and the y. So this new equation now becomes x equals 3y minus 1. Step 2, we need to work on solving for y. Step 2. So this becomes x equals 3y minus 1. So first step to get y by itself. We want to add 1 to both sides. So now we have x plus 1 equals 3y. So we still want to get y all by itself. 3 and y are being multiplied. We have to undo that. So that means we need to divide by 3. So we have x plus 1 over 3 equals y. Step 3. Write it in inverse function notation. So we write the inverse of f of x equals x plus 1 all over 3. So the next thing to do would be to graph it. So we have f of x equals 3x minus So put it in your calculator. So y equals 3x minus 1. Graph it. And it looks something like that. We can double check what values we have. So we have -2 and -7. -2, 1, 2, 3, 5, 6, 7. -1 and 4. 1, 2, 3, 4. 1, 0, -1. 1 and 2. 2 and 5. 3 and 8. So there is our 3x minus 1. So let's look at y equals x plus 3. I'm sorry, x plus 1. So I'm going to do parentheses, x plus 1. That quantity divided by 3. Graph it. So when you take a peek at this, it looks possibly, if you kind of tilt it, does it look like it's a reflection? So I'm going to look at my table of values and plot this one. So I'm looking for whole numbers that are nice. So -4 and 1. -4 and -1. 1, 2, 3, 4, -1. -7 and 2. So -1 and 0. 2 and 1. 5 and 2. And 8 and 3. So this is our inverse. And it should reflect over the y equals x line. So I'll put in another color here. So what we should see is the same distance on either side. If it's a true reflection, we should have the same distance on either side of this. This is our line of reflection. This is y equals x. This is y equals 3x minus 1. And this is y equals x plus 1 over 3. So we substituted the f of x with y. We flip-flopped the x and the y. We solved for y. And then wrote it with the function notation. We graphed the original, the inverse, and now we've taken a peek at whether or not it is truly a reflection over the y equals x. And it does appear that it's the reflection. So this x plus 1 over 3 is an inverse of 3x plus 1. As far as the domain goes, we have all x values. We can put in both positive and negative x values. We're getting out both positive and negative y values. So we don't have any restrictions with the domain in the range. So for today, you will be working off of page 281, and you'll be working on problems 5 through 20 on. And if you're not sure what you need to do, please take a peek at the agenda, and and that will give you an accurate reflection of what we are working on today. If you have any questions, feel free to text me on the Remind app. Have a great day.